Okay, so quadratic functions, quadratic equations. We're going to look at two things. Today we're looking at the easy part of it. Tomorrow we're going to take what we do today, we're going to stretch it out, we're going to expand it, we're going to do one thing different with it. So we'll get the easy part today. So what we're looking at today, we're going to call this is vertex form. All right, and again, this is almost the exact same thing as when we did absolute values, where absolute value was a V-shaped graph, quadratic is going to be a U-shaped graph, and we'll kind of show you how to go through those. What makes a quadratic function is that you have x squared. Okay, you can have other stuff, but the main thing is that you have to have x squared. X squared is the highest power of x that we're going to work through. Okay, so they may talk about functions, they may talk about equations. So if it's y equals x squared, that's your equation. If it's f of x equals x squared, that's your function. Okay, so again, equation, function, it's the exact same graph. It does the exact same thing. The only difference is if it's an equation, it's y equals. If it's a function, it's f of x equals. Still all the same thing. Okay, and again, the biggest thing for this one is the graph is U-shaped. So when we did absolute value, it was a V-shaped graph where it was like this. The difference is it's a U-shaped graph when we're talking about quadratics, anything with x squared. Okay, technically, if you look at like the actual name of the shape of it, it's a parabola. Not a parabola, but it's a parabola. Okay, so what we're going to do is we're going to take like the easiest one we have like this, and we're actually going to graph y equals x squared. Now, for when we're doing these, just kind of like we did absolute value, you may have to do this on the first couple of ones in the homework. When we get to a test, I'm not going to ask you to make a T-chart like this and plot, 8, 9, 10 different points. We're just going to show you this one just so you kind of got the idea of what's happening with it. After we do this one, then we'll kind of show you the shortcut on how we're going to do everything else. So. Okay, so for this one, we're going to plug in 5 points. We're going to plug in 2, 1, 0, negative 1, negative 2. Okay. And again, when we're plugging these in, just to be on the safe side, anytime we plug in x here, we're going to put it in parentheses. So it's 2 squared. Okay. 2 times 2 is 4. So if we write out the ordered pair that we're going to have to plot, that's going to be at 2, 4. Okay. And again, if you want to kind of, let's go ahead and put y equals down this one, you can do that. Okay, so if x is 1, it's 1 squared. 1 times 1 is 1. So that's ordered pair 1, 1. Plug in 0. 0 times 0 still does 0. So that's still at the origin. That's still 0, 0. Okay, so now if you do negative 1 squared, what's a negative times a negative? That's positive 1. There we go. And if we plug in -2, again, negative times negative makes that a positive. 2 times 2 is 4. Okay, and as far as points, that's when we could plot, 10 more points if we want to. But as far as just being able to graph something, that should be good enough. So over here beside it, I'm going to take these points we've got and just make a chart over here. Okay, so there's our graph. And again, the first point was at 2. 1, 2, 3, 4. Second point's at 1, 1. Next point's at 0, 0. This point's at -1, 1. This point would be at -2, 1, 2, 3, 4. Okay, and again, the big difference is that if this was, if we were doing absolute value of x, this was a v down and a v up where it had that sharp point. The biggest difference is when you graph this one, when you get to the bottom, it doesn't have a sharp point; it's just curved. We'll do something like that. Okay, now, and again, and that's the big difference is that everything we're doing, anything with x squared, it's always going to be this U-shaped graph. Anything with absolute value, it's always a V-shaped graph. And we'll show you one little trick that you can do for this one as we go through. Now, here's a couple of things to note. This point at the bottom, just like we talked about with the absolute value, this point at the bottom, 0, 0, that is your vertex because it's at the bottom of the graph in this case. Okay, and just like we talked about before, it's at the bottom of the graph, so when we talk about the vertex, it's a minimum. Again, it's a parabola when we go through this. Now, two other things actually we're going to add to this one. Is they're going to ask you to draw a line of symmetry. And when you draw a line of symmetry, you draw it right through the middle of the vertex and you draw a vertical line. So when they talk about an axis of symmetry, so that's kind of one of the new things we'll add in for this part today. That's just a vertical line drawn through the vertex. Okay, now here's the other good thing with this one, because I always wanted an equation of this one. The equation is always x equals, and it's always the x value of the vertex. So whenever you find your vertex that's here, whatever this number is that's here would go here. So for this one, now, and when we talk about axis of symmetry, so we don't have to write it out every single time. For me, you'll see me just put AOS for short. So for this thing, this green line that we drew back over here that's dashed on this part of it, that's our axis of symmetry. And it's just x equals this 0 that's here, that will go there. So once you've got your vertex, they're going to ask you to find the axis of symmetry, and whatever that x number is that's here, that's what you put there for that x equals for that part. Okay, so again, almost exact same thing as absolute value. This one's a U-shaped graph instead of a V-shaped graph. Okay, and just like when we did absolute, now here's the shortcut. When I ask y'all to graph these in the homework, and I ask you to graph these on the test, you are not going to make this chart out to do this thing. Now, if you want to, feel free to go ahead and do that if you need to. But I'm not going to make you do that because it kind of slows things down. It takes a while. But again, if you want to do that, you can. Here's what I'm going to ask you to do to graph one of these. Oh, get it straight here. There we go. I'm going to ask you to do two things. Number one, you're going to plot the vertex. Okay, so just like we did with absolute value, you're going to plot the vertex, you're going to put that point down, and then the second thing we're going to do is we're going to use the, just like we had the kind of slope, for absolute value, we still have something that's kind of like slope for quadratics. So we're going to use the kind of slope to get to the next point on the graph. Okay. Now, one thing one little detail, we're not going to worry about it because we'll make it this way. If this kind of slope is a fraction, if it's like 1/2 or 2/3 or something like that, this trick doesn't work. You have to go back and make a table like this and plug in the numbers. But for all the problems we're going to do, we're going to make it so this thing is a whole number, and it will work every single time that we're going to use our kind of slope to kind of get to the next point and do what we need to do. So it works every time with absolute value. It only works with whole numbers for quadratics. But every one of these I'm going to give to you test-wise should be a whole number. The problems I picked out on Math Excel are supposed to be whole numbers, but sometimes they'll mix in a fraction, but hopefully they're not going to. So. Okay, so here's the form. Here's what we're looking at. This is how we're going to be able to find the vertex off this thing. All right, and if you remember I'm going to flash back here real quick, how we had this for absolute value. It was a times x minus h plus k with absolute value. For quadratics, it's almost the exact same thing. It's still a times x minus h plus k. The big difference is, instead of using absolute value, they put a parentheses with a square there. So again, that's graphing form, vertex form of a quadratic, and that's what we did for absolute value. So it's the exact same thing, but instead of having absolute value, we've got this thing squared. So it's x squared that we're looking for. Okay, and everything still means the exact same thing. The h and the k. Again, change this sign from negative to positive. This sign stays the same. That is still the vertex. And your a value that's here is still kind of like the slope. Okay, so again, as far as all the numbers and everything we're doing, it's all the exact same thing. The a value, still the slope, kind of like the slope. The h and the k, that's still how we find the vertex. It's still, if it's at the bottom of the graph, it's still a minimum. If it's at the top of the graph, it's still a maximum. Just the only thing different is that when we graph it, instead of it being a V shape, it's got to be a U shape as you go through those. All right, now what we'll do, and we'll kind of, even though we've talked about this with everything with absolute value, we're actually going to show you um, this part. So if you want to make like a little, make a T-chart here in the middle of it. Okay, so when we're talking about this A that we've got here, this kind of slope that we've got, it's going to tell you the direction of the graph. So even if we don't have the vertex back here, because some of these things we're going to do, we're not going to have the vertex tomorrow when we do this. Even if we don't have all this other stuff back here, if we've got the A value, we're going to be able to do like 4 or 5 different things off this graph and be able to get a bunch of stuff out of it. Okay, so if this A value, this kind of slope we've got here, if it is greater than 0, if it's positive, we're going to say that the graph points up. So another graph will look something like that. Okay. Now, again, we may slide it up and down and left and right and do all that same stuff with it, but if A is positive, if A is greater than 0, then we know the graph is always going to have, the ends of it are always going to point up if we go through this thing. Okay. Which means your vertex is always going to be a minimum, because if this thing looks like this every single time, the vertex is at the bottom, we know the bottom point is going to be a minimum. Okay. The domain. We already know what that answer is. It's still just like absolute value. It's still negative infinity to infinity. This part never changes. Same thing when we get over here. We'll show you the next one. That when we do, because the next thing we're going to do is A is negative, but we'll get that part next. Same thing with this one. As long as we're talking about x squared, if we're talking about absolute value, the answer is always going to be negative infinity to infinity for domain every single time. So a lot of times they won't even ask you for it because we already know what the answer is going to be. Okay, for the range, whatever this k value is, it's here. We're going to use that k value here, and since that's the minimum, we're going to start with that k value, and we're going to go up to infinity because we know the arrows are pointing up, so we know this thing is going up to infinity. So we're going to start at this number, which again is going to be the k value, and that's our minimum value. So just like we did with absolute value, just like we did with all the other stuff, when we find out what the max and the min was, this one's that same thing. If it's at the bottom of the graph, that's the minimum. And if they ask you what's the minimum value, it's the second number or the number that's on the outside of the parentheses that's here. Okay, and again, that's all stuff we've already done. It's just, all right, let's just make sure that we know that if the A value is positive, we know the graph has to look like this. We know the vertex is going to be a minimum, and the minimum value is whatever the second number is in the vertex, that's the k, which is also going to be the number that starts with the range here. So these two numbers, whenever we're going through those, the k value that's here, that's in the vertex, that's this number, which is also that number. So it just repeats a bunch of times as we go through this thing. Okay, and if the A value is less than 0, so if it's negative, then basically everything is kind of backwards. The graph points down. Okay. Now the vertex is at the top, so we know the vertex is a maximum. Okay. And again, we always know domain never changes. So any of these problems with the absolute value, everything on this test, if they ask you for domain, you automatically know what the answer is going to be because there's no trick questions on this one. It's negative infinity to infinity. Doesn't matter if it's absolute value. Doesn't matter if it's x squared. They're always negative infinity to infinity every single time. That part never changes. Okay. The only thing that changes is the range. And since this is the top number, because now it's pointed down, so now we know it's going to negative infinity. So negative infinity is the lowest number, and then the k is the top number. Because again, if it's the max, it has to be the biggest number. If it's the minimum, it's the smallest number. Okay, so what we're going to do, I'm going to give you 3 examples. We're going to go through those 3 examples. We're going to graph them. We're going to find the vertex. We're going to do the domain, the range, the max, or the min value. We're going to do all this stuff just to show you, everything that's coming out of this thing. Once everybody's caught up. So. All right, so here we go. Let me give you 3 graphs. We'll do these 3 graphs, and then we'll wrap this thing up and be done. Okay, so on all 3 of these, here's our directions we're going to put at the top of here. We're going to find the vertex. We're going to find the axis of symmetry. Again, we're just going to say AOS for short, so we don't have to write it out. We're going to find the domain. We're going to find the range, the max or the min, and then the value. And then we're going to sketch the graph. Okay, so we're going to get the vertex, axis of symmetry, the domain, the range, either the max or the min, and the value that's there, and then we're going to sketch this thing and see if we can get this thing figured out. Okay, now here's how easy it should be. All right, okay, their A value is 1. Because again, we're basically taking this thing back to here and we're figuring out what what we've got to figure out, we've got to figure out what the A and the H and the K are. That's the 3 things we got. So if there's not a number there, then our A value is 1. So we're thinking slope, that's 1 over 1. Now, and here's what you can do. That's positive. So we know the graph has to look like this, which means the vertex is at the bottom, which means it's going to be a minimum. Okay, and that's some of the things you can get just as soon as they give you a problem without looking at anything else back here. You can look at this and know whether it's going to be a max or a min and what the graph is going to look like just based on what's in front of X. So the stuff that's back here, we don't need that. That's the vertex part. This is telling us all the stuff that's going to happen with the graph that's here. So the A value is 1. Again, if we think like slope, it's 1 over 1. It's positive, so we know it's going to go something like this, which means the vertex, when we find it, it's at the bottom, which means it's going to be a minimum. Okay, so we know that stuff just by looking at it. Everything back here is where we're going to pull out the actual part of the vertex. So again, just change this sign from -2 to +2. That number stays the same, so there's your vertex. Okay, and whatever the X number is, it's here. You put X equals that number, and that is your axis of symmetry. and we just said this was the minimum, the other number that's here, 3, that's equal to your minimum value. So the first number is your axis of symmetry. The second number is either your max or your min value based on which way the graph is going to go. Okay, the domain, we know this one's never going to change. It's always negative infinity to infinity. That part never changes. Okay, the range. And here's where we tie this one in. Since this is the y value of the vertex, this y value has to go in your range here. Since this is the minimum value, that means this 3 has to go first because that's the lowest number in our range. And because it's pointed up, we know it's going up to infinity, so we know it's going to do something like that. Okay, and the great thing about that one is, did you have to do any math at all? No, you just have to look at it. All right, so now when you graph it, there's everything we need to graph it. So over on the side over here, just going to make a quick XY axis so we can graph this thing. Okay, if you go 3 wide, that should be plenty. If you go maybe 4 up, that should also be plenty. And you don't have to go any down because none of this was negative when we go through this part. Okay, so first thing is we're going to 2, 3. So going over 2 and up 1, 2, 3. That'll put the point right there. Okay, and then we're going to use our A value, which is kind of like our slope, which is over here. Oh, there we go. Our A value is 1 over 1, and again, it's positive. So from here, we're going to go up 1 and over 1 to the right side. Starting back at the origin, or back at the vertex here, we're going to go up 1 and 1 to the left to get the next point there. And now, as far as graphing these, that's all you have to do. So the rest of it, you're just going to make this thing curve and make it look U-shaped. Because again, if this was absolute value, the difference is this would have kept going straight this way. And again, that's the only thing you got to see that's different. Absolute value, you go straight out from the point from there. If it's x squared, you got to make it curve up if it's positive, or you make it curve down if it's negative. So again, the number that's here, that's your y value, which is your max or min value, which is your first or your second number. If it's minimum, it's the first value. If this was max, it'd be the second number. Okay. Now, test-wise. Oh, now, some of the homework problems, and this is kind of 50-50. On the test, I'm not going to ask you to draw an axis of symmetry. On some of the homework problems, they're going to ask you to draw an axis of symmetry. That in Math Excel, you just have to look and see because it will tell you whether or not to draw one. If it asks you to draw an axis of symmetry, you would just go back and you would draw a dashed line. It would look something like that. Okay. Now, again, test-wise, I'm not going to ask you to draw the axis of symmetry. There's just one other thing we've got to worry about. But some of the homework, it's about 50-50. Some of them will ask for axis of symmetry. Some of them don't as you go through this thing. Do a couple more of these. All right, so for example 2, let's go with 2 times x plus 4 squared. Yeah, and again, we'll find all those same things. We'll find the axis of symmetry, the domain, the range, the max, the min value, all that stuff that's there. All right, so first thing is we know the A value is 2. But again, if we treat it like slope, it's 2 over 1. Okay, and again, with that being positive, We know that when we're doing the graph on this one, the graph would have to look something like this, which puts the vertex at the bottom, which means, again, it's going to be a minimum point. Again, that one value of 2 in the front, whatever's in front of x tells you those things that you know what's going to do. You know how to get to the next point from the vertex. You know what the graph is going to look like. And if you know what the graph looks like, you know where the vertex is, you know if it's going to be a maximum or minimum. Okay, and again, everything behind it is all vertex stuff. So we're going to change this from +4 to -4. There's nothing back here, so it makes it a 0. Okay, so there's our vertex. All right, for the axis of symmetry, it's just the x value, so it's x equals -4. If it asks for the max or min value, and again, we said we know it's going to be a minimum, so we know it's going to be a minimum back here. The minimum value is going to be this number, which is 0. So once you've got the vertex, the first number is your axis of symmetry. It's just x equals. The second number is the max or min value, just based on which way the graph is going. All right. Again, the main, we know it's -infinity to infinity because it never changes. It will always be that exact same answer. The one that changes is the range. Okay, so this is the minimum. So we're going to start with that number, and then we go to infinity. Okay. Oh, now one thing I have noticed, and this sometimes will happen. Instead of putting this answer like this, because the range is still your y value, sometimes they will do this. They will tell you that y is greater than or equal to 0. So they'll kind of let you go back and forth on this one. They may give you the range like this. They may also let you do the range like that. So just realize they could kind of go back and forth there. If we back up for just a second, back up on the range on this one, same thing. This would have been y greater than or equal to 3. Okay, and then graphing this one, we're going to -4, 2, 3. Okay, so vertex, -4, 0. So that's it. 1, 2, 3, 4. That'll put us right there. Okay, and again, our a value is 2 over 1. So again, that's kind of like slope. We're going to go up 2 and over 1 to get this point. Start back at the vertex, go up 2, and then back 1 to the left to get the next point. Again, that's all you have to have for me. And pretty much Math Excel should be all they ask for too. Sometimes I just ask for 1 or maybe 2. Curve it around so it looks something like that. All right. Again, they may or may not ask for that. This one we'll leave it off. If they ask for the axis of symmetry, we would have gone back and just drawn a dash line right through here. But they didn't ask for it, so we don't have to put it. All right, one more, and then we're done. Everybody good there? Everybody still writing that one down? Oh, hang on. Okay. And again, here's what we can get. Here's the easy stuff you get without having to do anything all just other than looking at it. Everything in front of the x squared tells you what you're doing for the graph on this one. It's negative 2x squared. So the a value in that case is negative 2. Yeah, if we think about slope, it's like negative 2 of 1. But the main thing is it's negative, so you know the graph has to look something like that. All right, and that's our graph. It's the vertex at the top, which means now it's going to be a maximum. Okay, so again, that's what that part gets. Where you've got everything in front of the x, that tells you whether it's max or min, tells you how much to move to get to the next point once we find the vertex, and then everything back here tells us how to find the vertex part of this. Now, if you notice, there's not a parentheses, right? If there's no parentheses, that means that that first number in the vertex is 0. We do have a number on the back side back here that's not in the parentheses, so that's the second number. So if there's not a parentheses, you know the first number has to be 0. Okay, and again, once you've got the vertex, everything else is just copying the numbers. The axis of symmetry is x equals that number. Again, we know that's a max value. So the max value is the y number. Okay. The main we know never changes. It's negative infinity to infinity. For the range, since that's the biggest number, that stops. So it's negative 3 here. So, and again, it's pointed down, so we know this thing goes down forever. So it's negative infinity, and we're going to stop at negative 3. Wait, now here's the other thing with the inequality, with the y greater than less than. Here's where this gets actually a little bit easier. I actually like this one with the inequality part better because your arrows are pointed down, correct? Down is always less than. So when they talk about the range in this case, if they just do y greater than or less than equal to, because the arrows are pointed down, that's less than or equal to. And it's just that number right there at negative 3. So again, sometimes they do it this way, sometimes they'll let you do it that way. Just kind of be okay moving back and forth on those. All right, one more graph over here and then we're done. Okay, so there's our x-y axis. Okay, again, start it with the vertex. Vertex is at 0, negative 3, so start at 0. We didn't go in. There's no parentheses, so there's no side-to-side movement. We're just going to go down 1, 2, 3 spaces and put that one right there. Okay, our kind of slope was negative 2 over 1, so we're going to go down 2 over 1 this way and down 2 over 1 that way. So we got a graph that looks something kind of like that. Okay. Now, one other thing they might ask you to do on some of these graphs, they might ask you for a x-intercept, which in this case there's not one. They might ask you for a y-intercept, which in this case would be this point right here. So they may still throw an x-intercept or y-intercept answer at you as you go through those, but that's stuff that we've been doing, so I think everybody hopefully should be okay there.